Welcome to your deep dive. This time we're diving into DeepWalk, online learning of social representations.
Yeah, it's a paper all about getting computers to understand social networks.
So giving our code a crash course in the language of friendships and connections and communities.
Right, exactly. Imagine being able to predict who someone might become friends with.
Just based on their existing connections.
Yeah, or even uncovering these hidden communities within a network.
That's so cool, I'm already hooked.
Yeah.
But before we get too deep, let's step back for a second.
Okay.
Why is network data so hard for computers to understand in the first place?
Well, networks can be incredibly complex.
Right.
Uh, think about it this way. What's the difference between a neatly organized spreadsheet and just a giant tangled web?
Yeah.
For a computer, analyzing a network, it's often trying to make sense of that tangled web.
Okay, that makes sense. So how does DeepWalk tackle this?
Well, DeepWalk takes kind of a unique approach.
Right.
It uses these random walks through the network, almost like a little digital explorer hopping from one connection to the next.
So it's learning by exploring.
Yeah. And
Yeah.
as it takes these walks, it's observing, the patterns of connections.
Oh,
Almost like learning a language by observing how words are used together
right.
in sentences.
So it's kind of like how we learn about a new city by wandering around the streets.
Exactly. That's
Yeah.
a great analogy.
Yeah.
And what's really fascinating is how this whole idea ties into the world of language models.
I remember reading about that in the paper, but I'm not sure I fully grasped it.
Yeah, so the paper draws this really compelling connection between the way that words appear in sentences and how people are connected in networks.
Now that you mention it, I do remember that, but how does that connection actually work?
Okay, so think about those predictive text features on your phone.
Oh, yeah.
They use these language models to try to guess what word you might type next based on the words you've already typed.
Hmm.
DeepWalk applies a similar concept to networks. So by analyzing the patterns in its random walks, it learns to predict which connections might be most likely given the structure.
That's really clever. So instead of forcing the network into some kind of structured format,
Right.
DeepWalk is learning its own grammar
Yeah.
of social connections.
It's like a grammar of connections
Right.
through exploration.
Through exploration. That's amazing. What kind of benefits does this offer for programmers like me?
Well, it gives us a really powerful set of tools. Imagine building a recommendation system
Okay.
that suggests friends or collaborators
What?
based on, the structure of a network,
What?
or even systems to spot unusual patterns that could point to security threats.
So we could apply this to things like understanding relationships between software components,
Exactly.
or maybe identifying clusters of related functions in a code base.
Yeah, absolutely. The applications go way beyond just traditional social networks.
Right.
And what's even more impressive is that DeepWalk is designed to be really scalable.
That's a key point.
It can handle these massive data sets we encounter in the real world.
Yeah, we often run into limitations with traditional methods when the data gets too big.
Exactly.
In the paper, they mentioned testing DeepWalk on some real-world data sets, right?
Yeah.
What were some of the key findings from those experiments?
So one of the most significant findings was that DeepWalk often outperformed other methods,
Okay.
even when those other methods had access to more information, which really highlights its ability to extract meaningful insights, even from a very limited view of the network.
It's like it can see the signal through the noise even when the data's sparse.
Exactly.
That's impressive.
And it achieved this was on diverse data sets, including blog catalog, Flickr, and even the enormous network of YouTube.
So it's not just theoretical, it's been proven to work in the real world.
Yeah, it's the real deal.
I'm completely on board with the potential here, but I'm still a bit fuzzy on how DeepWalk actually learns from these random walks.
Okay, yeah.
Can we walk through that process a bit more?
Yeah, absolutely. Let's start by imagining DeepWalk as a student exploring a massive library.
A library full of interconnected books and knowledge.
Exactly. So each book represents a node in the network, and the connections between them, like the citations and references, they represent the relationships we're trying to understand.
Okay.
So DeepWalk begins its journey by randomly selecting a book, any book, and just diving in.
So it starts at a random starting point and then follows the connections, kind of like following a trail of breadcrumbs through the library.
Precisely. So it might hop from a book on philosophy to one on history, then to another one, creating this chain of connections. And as it takes these random walks,
Right.
DeepWalk is carefully observing which books tend to appear together.
Like noticing that books on certain topics are often clustered together on the shelves.
Exactly. And
Huh.
just as language models learn to predict the next word in a sentence,
Right.
DeepWalk learns to predict the next book or the next node in its random walk.
So it's building a model, an understanding of how these connections are structured.
Precisely. And the key is that DeepWalk doesn't treat each book, each node, as just a simple isolated entity.
Okay.
It represents each one as a vector, a point in multidimensional space.
A vector. I'm familiar with that term from math, but how does it apply here?
Okay, so think of it this way.
Okay.
Each vector represents a unique location on a map. So books that are closely related, they share many connections, will have vectors that point in similar directions.
Gotcha.
Books that are completely unrelated will have vectors pointing in like opposite directions.
So DeepWalk is creating a sort of map of the library,
Yes.
where the location of each book reflects its relationship to all the other books.
Exactly. It's translating this complex web of connections into something that a computer can understand.
It's fascinating how it does that.
And the beauty of it is that by using these vector representations,
Yeah.
DeepWalk can capture that rich interconnected nature of networks in a way that's both computationally efficient and incredibly insightful.
This is starting to click for me. So by taking these random walks and observing which nodes appear together,
Right?
DeepWalk learns to position each node in this multidimensional space
Yeah.
in a way that reflects its connections to the rest of the network.
That's the essence of it. It's
Okay.
a really effective way to turn this tangled web of a network into something that computers can really easily understand and manipulate.
Okay, I'm following you so far. But how does DeepWalk actually go about learning these vector representations from its random walks? Like, what's the magic happening behind the scenes?
Well, it uses a technique called skipgram, which was originally developed for language modeling.
So we're back to the language connection.
Exactly. So remember how we talked about predictive text?
Yeah.
So skipgram works in a similar way. It's all about understanding the relationships between words by observing how often they appear near each other in sentences.
Uh-huh.
DeepWalk adapts this idea to networks, using the random walks as its sentences and the nodes as its words.
So instead of predicting the next word in a sentence, DeepWalk is trying to predict the next node in a random walk.
That's right. It's essentially asking, given that DeepWalk is currently at this node, what are the most likely nodes it will visit next?
Based on the structure of the network.
Based on the structure of the network, exactly.
And by repeatedly asking that question, taking all these random walks and making these predictions,
Yeah.
it starts to refine those vector representations,
Right.
getting better and better understanding the network with each walk.
You got it. And it accomplishes this through a process called stochastic gradient descent,
Okay.
which essentially means it's constantly adjusting the vectors based on the feedback it receives from its predictions.
So it's a self-learning system that continuously improves with every step it takes.
Precisely. And the beauty of this approach is its efficiency. So DeepWalk doesn't need to analyze the entire network all at once. It can learn incrementally, bit by bit, from these short, localized, random walks.
This makes a lot of sense. So we have DeepWalk exploring the network through these random walks, making predictions about the next node it will visit, and constantly refining its understanding based on those predictions.
Yeah.
But there's one piece of the puzzle I'm still not quite grasping.
Okay.
You mentioned hierarchical softmax earlier.
Right.
What role does that play in all this?
Yes. Hierarchical softmax. It's a crucial piece that makes this entire process computationally feasible.
Sure.
When you're dealing with massive networks, potentially with millions or even billions of nodes.
Trying to predict the next node out of all of those would be a nightmare.
Absolutely.
Yeah.
That's exactly where hierarchical softmax comes in.
Okay.
It essentially organizes the nodes into a tree-like structure,
Cool.
kind of similar to a family tree.
Okay, I'm intrigued. Tell me more about this tree structure. How does it help?
Okay, so imagine instead of searching through an entire library, you could first narrow it down to a specific section,
Okay.
then to a specific shelf, and finally to a particular book.
So it's breaking down this complex problem into a series of smaller, more manageable steps.
Exactly. Hierarchical softmax allows DeepWalk to kind of navigate down this tree, making a series of much simpler decisions at each branch.
Okay.
So instead of considering every single node at once, it can ask, is the next node likely to be in this branch of the tree or that one? And then it can narrow down the search from there.
It's like playing a game of 20 questions with a network,
Yes.
gradually zeroing in on the most likely candidates.
Exactly. So this hierarchical approach drastically increases the efficiency of the prediction process, especially when you're dealing with very large networks.
Right.
Without it, analyzing these networks would be computationally impractical.
Okay, that clarifies things a lot. So we have DeepWalk taking these random walks, predicting the next node, and using this clever hierarchical softmax trick to manage the complexity of these massive networks.
Exactly.
But how do we know if all of this is actually working? How do we measure the quality of these vector representations that DeepWalk is learning?
That's a great question, and it's where the real-world applications come into play.
Okay.
So to evaluate DeepWalk,
Yeah.
researchers use the learned representations to tackle a variety of network-related tasks, like multi-label classification.
Now we're talking, how did DeepWalk perform in these real-world tests?
Well, let's just say it passed with flying colors, and that's what we'll delve into next.
Okay, so spill the beans. How did DeepWalk stack up against the competition?
Well, DeepWalk consistently outperformed other state-of-the-art methods.
Okay.
Especially when you know it had limited labeled data.
That's really interesting. Can you give us like a concrete example?
Yeah, sure. Let's take a look at multi-label classification.
Okay.
So imagine a social network like blog catalog.
Okay.
Where users can belong to, various interest groups.
Right.
DeepWalk's task was to predict which groups a user belonged to based solely on their network connections.
So it's like trying to figure out someone's hobbies just by looking at who they hang out with.
Exactly. And DeepWalk was really good at it.
Right.
Even when, only a small percentage of users had explicitly stated their interests, DeepWalk could accurately predict those multiple labels.
Based on their connections.
Just based on their connection.
It could decipher those hidden patterns and make accurate predictions, even with sparse data.
Right. And it wasn't like a one-off success.
Okay.
They tested DeepWalk on various networks like Flickr and YouTube.
Yeah.
And the results were consistently impressive.
So DeepWalk's not just a theory, it's a proven approach.
It delivers.
It delivers, yeah.
Yeah.
Now let's bring this back to our programmer audience.
Okay.
How can they use DeepWalk in their own projects?
So imagine building a recommendation system.
Okay.
Instead of just relying on, user ratings or purchase history, you could use DeepWalk to analyze the network of user interactions and then recommend products based on what similar users in the network have bought.
So tapping into that collective wisdom of the network.
Exactly.
Make smarter recommendations.
And think about fraud detection.
Okay.
You could use DeepWalk to analyze financial transactions looking for unusual connections that might suggest suspicious activity.
So it's like giving our algorithms a sixth sense, an ability to spot those anomalies that traditional methods might miss.
Yeah, it's like adding this extra layer of intelligence
to
your system.
The potential applications are vast.
They are. From analyzing code bases to understanding complex biological networks, the possibilities are really exciting.
This has been an incredible deep dive. We've gone from, the theoretical foundations of random walks and vector representations.
It's been a journey.
It's been a journey to the mind-blowing real-world applications of DeepWalk.
Right.
But before we wrap up, I have one final question.
Okay.
What's the key takeaway you want our listeners to walk away with?
Well, I want them to remember that DeepWalk offers a new perspective on networks.
Okay.
It shows us that the structure of connections can be just as valuable as the individual data points themselves.
So it's not just about what we know, but who we're connected to.
Precisely. By learning to speak the language of networks, we can unlock this whole new level of understanding and insight into the world around us.
That's a really powerful thought.
It is.
This has been your deep dive into DeepWalk.
I hope you enjoyed it.
We hope you've enjoyed the journey, and we'll see you next time.
See you next time.
For another exciting exploration into the world of cutting-edge technology. So we've seen how DeepWalk can uncover these hidden patterns and make accurate predictions, even with limited data.
Yeah.
But can you give us a more concrete sense of how well it actually performs? What kind of results do they see in the paper?
The results were remarkable. In those multi-label classification tests, DeepWalk achieved accuracy scores that were significantly higher than other leading methods.
Can you quantify that a little bit?
Sure.
Give us some numbers.
Yeah, for example, on the blog catalog dataset, with only 10% of the user interests labeled, DeepWalk got an accuracy of over 80% in predicting the correct labels.
Wow.
Which was significantly better than other methods that struggled to even get 60% accuracy with the same limited data.
So DeepWalk isn't just slightly better, it's like a whole different ball game when it comes to analyzing networks.
It's a game changer, especially when we have sparse data.
Especially with sparse data, yeah, that's amazing.
And remember, these results were consistent across different networks, demonstrating the versatility and power of DeepWalk as a general purpose network analysis technique.
Okay. This is incredibly exciting. Now let's talk about how programmers can actually use DeepWalk.
Okay.
I'm already like brimming with
I
ideas.
bet you are. One area where DeepWalk could be super useful is code analysis.
Okay.
Imagine using it to analyze the relationships between different functions or modules in a large code base.
We could identify clusters of related functions or pinpoint potential areas for refactoring.
Exactly. It's like having an AI-powered code navigator.
That would be amazing.
And think about security applications.
Okay.
DeepWalk could be used to analyze network traffic patterns
Right.
to help detect anomalies that might point to some kind of malicious activity.
Like giving our security systems a boost of intelligence,
Yeah.
allowing them to spot threats that they might otherwise miss.
Yeah, it's like adding this whole new layer of awareness
Yeah.
to your security setup.
It feels like we've only scratched the surface of what DeepWalk can do.
We have, from social network analysis to bioinformatics,
Yeah.
from cybersecurity to marketing, anywhere you have data that can be represented as a network, DeepWalk has the potential to unlock these really valuable insights.
This deep dive has been a real eye-opener. We've gone from, random walks and vector representations
Yeah, it's been quite a journey.
to these amazing real-world applications.
A real deep dive.
Yeah, so as we wrap up, what's the one key takeaway you want our listeners to remember?
I want them to remember that DeepWalk fundamentally changes how we view networks.
Okay.
It highlights that the structure of connections is just as important as the individual data points themselves.
It's not just about what we know, but who and what we're connected to.
Exactly. By learning to understand and harness the power of those connections,
Right.
we can gain a deeper understanding of the world around us.
It's like DeepWalk gives us this new lens through which to view the interconnectedness of information and relationship,
It's a new way of seeing the world.
and even our code.
And with this new lens comes the ability to create smarter systems, make more informed decisions,
Yeah,
and ultimately shape the future of our interconnected world.
that's amazing. This has been your deep dive into DeepWalk. We hope you've enjoyed the journey, and we'll see you next time for another exciting exploration into the cutting edge of technology.